Hypothesis testing for variance. A weather service claims that the standard deviation of the number of fatalities per year from tornadoes is no more than 25. A random sample of the number of deaths for 28 years has a standard deviation of 31 fatalities. At alpha equals 0.10, is there enough evidence to reject the weather service's claim? Well, this is going to involve using a chi-squared test for variance. And the first thing that we want to do is go ahead and state the claim mathematically, verbally, and then also identify what the null and alternative hypotheses are. So the claim is the number of fatalities is at most 25. So we need to go ahead and write our null hypothesis, and we need to write our alternative hypothesis. The null hypothesis is going to be simply stated as the standard deviation is less than or equal to 25. Now notice that in this particular problem we're dealing with standard deviation. You're going to use the standard deviation just like you would use variance, and you would square the standard deviation to get variance, and that's how we're going to do the test. So if the question it said claims that the variance is, then you would just go ahead and work with that number. But since we're looking at standard deviation, we are going to have to square the value in order to perform the proper test. So the alternative hypothesis will be sigma is less than 25. I'm sorry, greater than 25. So remember that this is the claim, and this value right here tells me that it is a right, or I should say symbol, is a right-tailed test. So you'll see that I've gone ahead and underlined standard deviation, and the claim is no more than 25. So the next thing that we want to do is go ahead and identify the level of significance, alpha, and the degrees of freedom. In order to do that, we simply go into the problem, and we'll look at alpha being equal to 0.10. So alpha is equal to 0.10. And then we're going to talk about the degrees of freedom. Well, for degrees of freedom, we're going to use this simple formula, df is equal to n minus 1. Remembering that n is going to be equal to the number in the sample space. And in this case, the sample space is going to be the number of deaths for 28 years. So n is equal to 28. So degrees of freedom for this problem is going to be given as 28 minus 1, which will be equal to 27. So we've identified our alpha, we've identified our degrees of freedom, and we know that this is a right-tailed test. So if we go ahead and look at the graph that we would be drawing for this, the graph looks roughly like this. And we know, since this is a right-tailed test, that chi-squared naught will be at this point, and that we will reject anything that is above the chi-squared critical value. So in this case, let's go ahead and determine what that is from the table. Okay, so here's our table. And we know that the degrees of freedom is 27. So we'll be looking at this row here. And we also know that alpha is going to be 0.01, which is going to be right here. So we'll be looking at this column. and where the two intersect is going to be our chi-square value. And that's going to be equal to 36.741. So we can write that right here as our cutoff value. So anything greater than that, as far as the chi-square test, is going to fall into the rejection region. So now what we want to do is go ahead and find the standardized test statistic for this particular problem. So that's going to be step number 3. And for this, we're going to use technology, and that technology will be StatCrunch. Now, you should already know how to open up StatCrunch if you've watched my introductory video concerning StatCrunch. And this is going to be important because it's going to give us quite a bit of information. So let's go ahead and look at what it's going to look like in StatCrunch. So you've opened up StatCrunch, you're going to left click on Stat, then you're going to scroll down to where it says Variance Stats. You then want to highlight one sample and you want to select with summary, which is going to give us a pop-up window. And in this pop-up window, we're going to put in the sample variance. But remember that we don't have sample variance here. Let me show you what I'm talking about. We have the sample standard deviation because that's what's given to us right here. Well, how do I find the sample variance? Well, this standard deviation for the claim is 25. The standard deviation, which is going to become the variance, is 31. So we will take the standard deviation of 31 and convert that into the variance by simply squaring the value. And notice that I'm going to identify this standard deviation with a sub s and this variance with a sub s to represent sample. I also need to look at the fact that the claim is no more than 25. So the standard deviation claim is equal to 25. Therefore, the variance for the claim will be equal to 25 squared, or 625. Well, now that we know this, we're going to go ahead and use StatCrunch. So let me scroll down to right here, remembering that we have a variance for the claim to be equal to 625, and then we have the variance for the sample, and that's going to be equal to 961. And keeping in mind that n is equal to 28, and that's going to be important. So let's look at StatCrunch and let's plug these numbers in. So the sample variance in this case is 961. Let me make that a little smaller. So type in 961. Your sample size is 28. The hypothesis test for the variance, remember that the value that we have here is 625. And it is a right-tailed test, so the alternative hypothesis will have the greater than. And then we simply left-click Compute. And that gives us this pop-up window. And this pop-up window has all the information in it that we need in order to go ahead and complete this problem. So looking at this, we see that using StatCrunch, the chi-square statistic is calculated to be 41.5152. So chi-squared critical is going to be 41, or calculated 0.5152. And if we go back and look at this very carefully, we know that the chi-squared that we generated from the table is 36.741, which means that this 41 is firmly in the rejection region. So since the chi-squared value that we calculated is greater than the chi-squared value from the table, we can reject the null hypothesis. So how would I state this? Well, simply stated, there is enough evidence at the 10% level of significance to reject the Weather Service's claim that the standard deviation of the number of fatalities per year from tornadoes is no more than 25. So therefore, we can read this as there is enough evidence at the 10% level of significance to reject the Weather Service's claim that the standard deviation of the number of fatalities per year from tornadoes is no more than 25. Another thing that we can look at is the fact that there's also a value in this pop-up called the p-value. The p-value method of determining rejection or fail to reject is simply this. Go ahead and do the exact same process that we're doing, except calculate the p-value. And if the p-value is greater than alpha, since this is a right-tailed test, reject the null hypothesis. Now, if the p-value had not been greater than alpha, you would fail to reject the null hypothesis. In addition, if this had been a left-tailed test, the p-value would be less than alpha, you would reject, and if it was greater than alpha, you would have failed to reject.